Hello beautiful people! Quite often you need to move your points in the particular direction, so it's quite nice to understand how to move your points with the curves, for example. When you draw some curve, move your points along that way. There are quite a few ways to do that in the Houdini as usual, but let's try to build something and to learn something together, because I'm just in the process of discovering the Houdini, and it's quite awesome piece of software, to be honest. All the simulation in this case, as I understand it, is a point-based simulation, and if you do it with your particles, you could do it with your RDB, because it's like representation of points. This piece could be, and you could do it with Vellum, for example, with cloth here, and so on and so forth. So you could build your assets and then just apply the same principle in different DOP contents. Obviously, I will not explain every step I will do, but let's talk it through. So create a geo. I will not call it anyway, so just leave as it is. Then we need to draw a curve. In this particular case, I want to change the projection type, not a type but projection plane, something like that. This is our center of our world. And press enter or click this button, so you could have this handle, and draw like a few curves to start with. So let's do something like that. Quite generally, after this step, you could check the representation of your points onto the curve with this button. It's like showing your points. You want to resample a curve because it's not even at all. You have two options: either maximum segments length with the lower number, the more it will print, the more points you will have, or the maximum number. I will go with maximum segments at this point. Just eyeball that and change this guy to subdivision curve. It's like giving me a little bit of curvy or smoother lines. After that, I want to create a sphere. Sphere. And this sphere will be our center of the point. Usually I just change that to polygon mode, different representation of your topology, give it quite a few segments to work with, and even here we could just lower the uniform scale. The next step would be to create a POPNetwork. This is a DOP content, meaning like a dynamic operator system with the preset. Like usually if you create your DOP, something like this, POPNetwork, basically the same, but it's empty inside. So connect to the first input and see what we got. In here we have this source first input, object, and output. That's it. We will build everything on this side. Usually I just turn that off, the guide, and turn this off to see what we got. And when we press play, you just have your points. Let's go through the main settings out here. Emission type, you could go with surface, points, and so on and so forth. Surface on the scar on the surface is okay for me. Go to the purse. We have two activation modes. So the first one is like count of particles per simulation frame, per substep. And the second one, I guess, the count your particles per second. So if I'm right, we have 5000 per 24 frames, and we could prove it like, yep, it's about right. We have this 5000 points and a bit more. So at this point, it's okay for me. I will not change it. And of course, if you want to turn of 1 you go with 0 at this point, and 1, this means this will activate it. So 1 for this one, 1 for this one. Life expectancy is lifetime of your points. You could go with something, it's in seconds, so maybe 2 seconds, and it's a good way to have some variation of your life. It means like you have some particles will have 3 seconds and some particle will have 1 second, because it's either plus or minus this parameter. We could go with negative jitter and back, and that's it for now. So how could you bring your curve into this system and move along the curve? For example, I could do, again, it's a Houdini, and we could do whatever you want, and there are many ways to do that the same step. So I will bring a pop wind, connect it in this stream, and give a little bit of velocity to the x-axis. So now we have the points moving to that direction. I would like to bring a little bit of an amplitude on the wind, maybe not that swirly, maybe a bit more. Yeah, it's okay to me. And I like to bring a drag, pop drag. It's like dragging your velocity over time. It's like underwater effect or something like that. Let's calm down our particles a bit. So now we have some gentle movement over there. And at this stage, I could bring a little bit more, and that's it. So now you need to create a null here. Try to bring our out curves. Please be curves to our system. Let's copy this node, just control copy while you're selected it. So go inside and let's bring some purple curve force. This is the very first and very robust way to move your points along these splines. Let's paste, control copy, control V in this SOP path and have something at least. You have some representation around your curves, and this is guides. I think we could lower that by max influence radius. I encourage you to investigate this node by yourself. Just quite a few air resistance, like how it will resist the air. Then we have influence, the radius of influence around that curve you bring. Then you have follow scale. It's like how strong it will follow this curve. So for example, if you go with 10, you see that this is quite fast. Then you have suction scale. It's like how much it sucked into the direction of the curve. Orbit scale, it's like a rotation around the curve in this direction. If you imagine this is a curve and you could rotate it in either the direction and other speed, as you could see, it's like moving around in this tube, invisible tube. And of course, inherent velocity is like if you have attribute of velocity on your curve, you could inherit this with this one. And some more settings out there. It's cool, I guess. You need to spend a little bit of time tweaking the settings, and I guess it's very powerful. But sometimes you need just, for example, for data visualization, you don't need such a house out there. Straight following the curve and let's go out. You could tweak it as you want, but let's go to the second method. Let's disconnect this guy and move it away. This time let's create a POPVop. POPVop. You need to do quite a few things. First, go to your input. Input 2, for example, you could do input 1. I just used to do input 2 because input 1 is like this one is itself. Paste the same link to this curve. The second one, inside, you want to update your position, right? For now, you have the velocity. You have the velocity in the direction of X, and some wind and some noise and so on and so forth. Let's create a min position node. Minimum position gives you the minimum position from the point to the input position. In this case, input number 2. It's correlated with this one. Probably you could plug that result in the position itself and see what you got. And now you see that we moved our points just straight along our curves. It's cool, maybe, but you want to have more freedom for that. In order to do that, you want to mix between your original position, which is this one, and your position along these curves. It's like a suction force for your particles. So let's create a mix node. I think in the VEX it's like similar to the lerp function, and this bias is what is driving our force to be how much it will allow for the points to go from these curves. For example, I could do this just a bit. So we have general movements from our wind, but we have the direction of these curves. I guess we need to increase the force. We want to give it a little bit of Z to compensate this one. Let me see. Or you could adjust your curve. For example, in the stroke section, you have 1, 2, and 3. Let's visualize which one is. Okay, this one, I guess, is the third one. Delete this one and just create the new one more closer to the source. So now it's updating and we have it. What we have? We have the general movement of your points along the curve, but let's say you love everything except it is not following your curve as you expected, as perfect as you want it to be. So this time we need to bring something new to the system. Let's go here and create orientation along curves. This guy will give you the normal vector. It's an attribute. It's like averaging the position between 2 points on these curves, I guess, and create a vector and so on. So you have this n, and in this case, you want to follow our particles more on this direction. This time we have SOP input number 2 the same, and just need to bring this data to our POPVop. Let's create this time XYZ Distance. This guy will allow you to bring any attribute, I guess. First one, it's distance to the closest point in the simulation. That's why we need a position of these points, and we need an input, the surface. So another one will be primitive attribute. This second node will allow you to read from the primitive and from UV. It's different UV from this one when you have the UV 0 to 1. It's like its own system of UV. It's a position on the primitive. And you could read here any attribute you want, and we want normal. So let's see what we got. And for example, if we update the position, I don't think it's work right. But if we update our, for example, velocity, it should give us exactly what we want. But this time it's cool maybe at first, and then it's super narrowing then. So usually when you do velocity and force, you have some velocity and force in your system already. So you want to add it to the existing velocity. Let's bring the velocity, add this one to the existing one, and that would update our velocity as a neat output. Maybe we need to multiply for a smaller number. Yeah, that's right. So multiply constant is the one that helps you to do that. Much smaller number. And now you control it, how much that will affect your system. For example, that much, or for example, much more. And now you see the speed and the direction. And now you could bring more of the noise, for example, in the system, or update your roughness, which is more rough noises, which is more energetic style of the effects. For example, some energy coming out of the hand of the character of this guy. And that's beautiful because what else can we do? We could randomize this bias based from the distance to the primitive, for example. This means like further away from the primitive have a much more influence to the points and suck it more, and closest points to this curve, well, I think it will have our initial noise. We could fit it, we could add noises to this system, and for example, if we don't do that, we could create a parameter and bring this parameter to the bias and call it offset, for example, label offset as well. And this parameter will go outside of that, and you have it here. So offset, you could control it from this level. More, or less. Of course, you could animate it, so that will bring you like from house to wood to some, I guess it's something like energetic system. And again, it's absolutely updated. You could draw more curves. Let's prove it. I guess something like that, something like that, and that. But as you guess, we have the wind direction. But let me see what we have. Whoa, it's super cool. It's not that strong in this direction, but it's super cool. Again, I guess we could animate the curve. If you have something to do, you could do whatever you want, you know? Just bring all the knowledge you have to this system and update it. The last thing I want to talk about is our volume. It's a bit more complicated than this one, but I guess it will give you more freedom to adjust your points in different direction noises. Let's try to build VDB. Let's start with VDB. It's like an empty VDB. Then we need to activate this VDB. Go to the left input, and this input will expect you some bound. So let's create a bound cube around our curves. Flat for now. Let's give it more size, something like 1, I don't care, in all the directions, and breathe inside. So now when you go to reference and the VDB activate, you have this volume, and this guy will control, I guess, your resolution. One thing you need to do is change the name to the velocity, whatever you want, but I will call it velocity, and change the type to vector float. So now when you see here, you have this velocity VDB with voxels information, right? Go to Volume VOP at the top level, bring this inside, and I guess we need to bring this curve as a second input. And you want to mix it, so the thing you would bind export is your velocity. So the same name as velocity val, and the type should be 3 float, and it's okay here. Now you want to create XYZ distance. The same logic, it's input number 2. So input number 2, position, our existing position, attribute primitive. We want to read normal, so it's a normal. File will be input number 2, primitive, UV, and bind as an export. We have something. I think we need to create a volume trail to see it properly. We need points to trail. Let's create a slice, volume slice, right? And let's create, I guess the second one is velocity volume, right? And I guess it's like some weird glitch, right? It's back. We could move this trail and see it is doing something, but it's hard to see what we're doing. So instead of volume slice, let's create a scatter. Our velocity, we see that this trails, and eventually our velocity will follow our curves. Let's do it this way. Out velocity, copy it. You could mix it with the noise inside, right? So just add some noise to this vector. For example, curl noise, I don't care. Just for demonstration purpose, and for example, add it with the existing trails, something like that. And we don't like to do it that much. Multiply constant and lower it, so we'll bring some noise to the level when we could still distinguish our direction, but have something to displace our curves. Again, copy it, go to our points, go to the start, and let's start to manipulate our position. Again, this one I don't need it for now, and let's bring advect by volumes, pop advect by volumes. This guy will allow you to move your points, so advect or update your velocity based on the volume you have. I will use a SOP as a source, paste our direction, our link to the node, proper node. I will update the velocity, and if you have another name, you need to change it here. I will update the position. Let's try to see what we have. We have it. Let's try to not to use our wind, so we just could focus on the direction. So we have, in this case, maybe final velocity and trace. It's like a more precise way to update our position. You could potentially update your velocity again with a trace, but I think, I don't know, I thought it could be a velocity scale problem. Again, bring some noise, you have the general direction, and that's it. So you have quite a few ways to do the same thing in Houdini, and it's cool. And I just slowly talking through all these ways, and maybe you have something new, maybe you have more of that. Please bring it, leave a comment and say, hey, you did it wrong, or you did it not perfect. So let's try to build something new together. Hope you learned something useful, and let's see you in the next one, I guess. Bye bye.